Today we're going to talk about rewriting equations with two or more variables. Suppose you're given this equation. You have y equals 4x plus 5. Well, this equation, we can find the slope and the y-intercept quickly because the equation is in the form y equals mx plus b. Y equals mx plus b, where m is your slope and b is your y-intercept. And this type of equation has a special name. We call this the slope-intercept form of the equation. And the reason why is you can see the slope and you can see the y-intercept when it's in this form. So this equation right here, I can quickly look and see my slope is 4 and my y-intercept is 5. Now, what would happen if I had an equation that looked like this? Negative 8x plus 2y is equal to 10. Could you find the slope and the y-intercept by just looking at that equation? Well, this equation is not in slope-intercept form, so I can't actually see the slope and the y-intercept when it looks like this. And we call this standard form. It is in standard form when the x and the y are on the same side of the equal sign. Here we have y by itself. Here we have x and y on the same side of the equal sign. So if I wanted to find the slope and the y-intercept, I would have to rearrange this equation and get it to look like y equals mx plus b. So to do that, I would have to solve for y. I would have to get y by itself. So here we have an equation with two letters in it, and we're going to solve for y. We're just not going to get it down to a number. We're going to have an equation. We want it to look like this when we're finished. And then we can find the slope and the y-intercept. So if I'm going to solve for y, and I like to draw a little arrow to the letter that I'm solving for. I'm solving for this y right here. So if I wanted to move this negative 8x to the other side, what would I have to do? Well, I would have to do the opposite of what's happening. I am subtracting 8x, so to get rid of it, I'm going to add it. And if I add it to one side, I have to add it to the other side too. Now, why did I do that? Well, these cancel out. And I'm left with just 2y. So I'm working towards getting y by itself. I just got rid of the minus 8x and moved it to the other side. Now on the other side, I can't actually add these together because they're not like terms. But I'm just going to write it like this. I'm going to say 8x plus 10. Now I almost have y by itself. What's the next thing I would have to do to get rid of that 2 that's right next to the y? That's multiplied. Well, the opposite of multiplying by 2 is dividing by 2. So I'm going to divide everything by 2. And when I do that and simplify, I end up with y equals 4x plus 5. I just simplify all my fractions. And you can see now that my slope is 4 and my y-intercept is 5. I could not see those numbers. Notice up here in the equation, I don't see a 4 and a 5 in the equation to begin with. That's why I could not say what my slope and my y-intercept were when it's in standard form. I had to solve it for y. So that's what we're going to do today is we're going to rearrange equations. They're going to tell us to solve for a certain variable, and we're going to use our algebra to get that letter by itself, just like if there were numbers in the equation instead of letters. So let's move on. Oh, one other thing before I forget. You might see them write your y-intercept like this. They also might write it like a point. So if we write b equals 5, that's the same thing as saying it's the point 0.05. Because if you graph this on your graph, you would be on the y-axis at positive 5. And that is the y-intercept. Okay. On the next part, it's going to say solve each formula for the given variable. They're going to tell you what letter to solve because there's going to be more than one letter in the problem. Now these problems are actually formulas that you see in math and science. So let's start with the area of a rectangle, which is length times width. I have this formula and I want to solve for the length. I want to solve for L. Instead of it being A equals, I want it to be L equals. Well, if I want to get L by itself, I have to get rid of the W. Well, what's happening with the W? I'm multiplying by W. What's the opposite of multiplying by W? That would be dividing. And if I divide one side by W, I have to do the same thing to the other side. Now, why would I want to do that? Well, if I'm trying to get L by itself, my W's are going to cancel. I have L by itself, and I cannot simplify this because I don't have any numbers in them, but I can write it as the area divided by the width. And I have solved this equation for L. I now have L equals instead of A equals. All right, number 2. Suppose you have the formula for Fahrenheit. Fahrenheit equals 9C divided by 5 plus 32. And I want to solve this for C. I have an equation that if I knew Celsius, I could plug it into this formula and find Fahrenheit. Well, I want a formula for Celsius. If I know Fahrenheit, I want to be able to find Celsius. So if I solve this formula for C, I will have my new formula. All right, so to solve for C, what would I have to do first? Well, in a regular equation, I always get rid of whatever's added or subtracted first, so that's what I'm going to do. I'm going to move 32 over to the other side. And when I do that, I get F minus 32, because I can't actually subtract it, equals 9C over 5. All right, I'm trying to get this C by itself, and I have that fraction right there. I have that number that's divided by 5 that's on the bottom. So if I could get rid of the fraction, then I would be closer to getting C by itself. So let's get rid of this 5 on the bottom. What's the opposite of dividing by 5? If I multiply by 5, and I would have to do it on both sides, my 5's are going to cancel, and I bring down my 9C equals. Now, I could distribute this, but I'm going to leave it. My goal is to just get C by itself, so I'm going to leave this other side the way it is. I'm not going to get rid of the parentheses. I'm just going to leave it just like that, because my goal is to get C by itself. And I only have one more step to go. What is the opposite of multiplying by 9? If I want to get C by itself, I want to get rid of that 9, I'm going to divide both sides by 9. My 9's cancel, and I get Celsius equals 5 times Fahrenheit minus 32 equals 9. So if I knew what the degrees Fahrenheit was, then I could plug that number in here, subtract 32, multiply by 5, and divide by 9, and I would have my degrees in Celsius. So now this formula I could use if I knew Fahrenheit. I could plug it in to find Celsius. Where this formula was, if I knew Celsius, I would plug it in to find Fahrenheit. But I got this formula by solving for C from this formula. Okay. Next page. Okay, problem number 3. The formula that they're giving us for this one is R equals D over T. All right, the rate equals the distance divided by the time, and we want to solve for D, for the distance. So if I want to get D by itself, I got to get rid of the fraction. So the opposite of dividing by T is multiplying by T. So when my T's cancel, I get D equals T times R. Now that answer's acceptable, but you guys are probably more familiar with this formula when we write it like this. D equals R times T. Distance equals rate times time. So of course I'll take either answer, but this one's a little bit more familiar. This one we would use if we knew the rate and the time, we could multiply and find distance. In this equation up here, if we knew the distance and the time and we were looking for rate, we would use that formula. Number 4. If you have I equals W divided by 12.6 R squared. And we want to solve this for R. Now this formula is the R is the distance to the light bulb, I is the intensity of light, and W is the wattage of the light bulb. So this is actually a formula you would use in science class. And we want to solve for R. Now, notice it's on the bottom of the fraction, just like the T was up above. So we're definitely going to get rid of the fraction first, and then we'll deal with the R squared at the end. So we are going to multiply each side by what's on the bottom. We have 12.6 R squared, and we have 12.6 R squared here. Multiply both sides by the same thing. These cancel out, and we're left with W equals 12.6 R squared times I. Now, our goal is to get R by itself. So we need to get rid of the 12.6 that's multiplied and the I that's multiplied. So the opposite of multiplying is dividing. So I'm going to divide both sides by 12.6I. And when I do that, my 12.6's cancel and my i's cancel, and I'm left with R squared is equal to W over 12.6I. Now, we have to get rid of the R squared. We just want plain R. So we still have one more step. Well, if you guys remember, we talked about the square root property. So if you have x squared equals 25, and you want to solve for x, well, you could tell by looking at this that if x was 5, and we squared it, we would get 25. So one answer is 5. But what about if we squared negative 5? If we squared negative 5, we would also get a positive 25. So algebraically, let's solve this. If I wanted to get x by itself and it's squared, I do the opposite and I take the square root. But if I take the square root of one side, I do the same thing to the other. But I have to get two answers. So I have to put my plus or minus sign in there. That is the square root property. When you take the square root of both sides, you have to make this side positive or negative. So when you take the square root of x squared, you can pull out an x equals plus or minus the square root of 25 is 5, and there you get your two answers. So when I do this problem over here, I have an R squared. I want it to just be R. So I'm going to take the square root to get rid of the R squared. But when I do that to one side, I have to do it to the other side. And the square root property says you have to say plus or minus. Now the problem with that, in this problem, this is like a real life equation. R represents distance, and you can't have negative distance. So when I actually write my answer, I'm going to ignore the negative part because you can't have negative distance. So I'm going to say R equals the square root of W over 12.6I. And I am not going to put the negative answer because it doesn't make any sense. So here is the formula you get when you solve for R, when you started with a formula where it was solved for I. We multiplied both sides by what was on the bottom, and then we divided by everything we didn't want to get this R squared by itself, and the last thing we did was we took the square root of both sides, but we only took the positive answer. Okay, next page. The directions will say solve for the indicated variable. Number 5. 3x minus 9y equals 12. And we want to solve for x this time. So we're not solving for y. They're not asking us to find slope and y-intercept. They just want us to solve for x. So to get x by itself, we have to get rid of the minus 9y. So I'm going to add the 9y to both sides. And I get 3x is equal to 9y plus 12. Divide both sides by 3, or divide everything by 3. And I get x equals 3y plus 4. The more we do of these, the easier they will get. It's just kind of weird because you don't actually get to subtract or add the unlike terms, but that's all right. And notice that I always put the letter first and then the number on the end. You don't have to do it that way, but that's what your answers will look like in your book. Okay, number 6. Suppose you have a formula or an equation that's already in slope-intercept form. So you can see the slope and you can see the y-intercept, but they want you to solve for x. So they want you to get x by itself. So to do that, I'm going to subtract 7 from both sides. I get y minus 7 is equal to negative 2x. I'm going to divide everything by negative 2 to get x by itself. Now, when I get something like this, I get x equals, when I get this part right here, I'm going to pull the number out in front of the y. So there's really a 1 right here. So I'm going to pull out a negative 1/2 y. And then these double negatives cancel, and I get plus 7 over 2. I have x by itself. Everything else is on the other side. I get some fractions sometimes. That's okay. All right, let's go ahead and turn the page. Number 7. Here you have m equals 7 minus 5 times n minus m. And we want to solve this for the letter n. Now notice in this problem, n is inside parentheses. Right there. And we want to get that by itself. Right now we have this m by itself over here, but notice we have another m over here. Doesn't really matter if we're solving for n. Let's just get n by itself. All right, so on this side I can't do anything yet. I have 7. I'm going to distribute the negative 5. So I get negative 5n. And negative 5 times negative m is positive 5m. So again, I'm trying to get this n by itself right here. So I want to move this and this. Is it okay if we go ahead and move those at the same time? Let's do it. Let's move the 5m over by subtracting. And let's move the 7 over by subtracting. So let's write down, well, these two will combine together. Negative 5m plus 1m would be negative 4m. Minus 7 is equal to, now these canceled out, and these canceled out, and the only thing I have left over here is my negative 5n. Getting close. I almost have n by itself, so what's the next thing I would have to do? The opposite of multiplying by negative 5 is dividing by negative 5. So I'm going to divide everywhere by negative 5. My negative 5's cancel. I get n equals, I'm going to pull my fraction out in front, and when I do that, I'm also going to cancel these two negatives out. So I have 4/5 m plus 7 over 5. And I have n by itself. All right, last one of these. Suppose you have x squared plus 4y is equal to, parentheses, x plus 6 times x minus 2. But we want to solve this for y. That means we want to get this y by itself. Well, let's rewrite this side because we can't do anything to anything over here yet. Let's get rid of the parentheses using distributive property twice. I say x times x is x squared. X times negative 2 is negative 2x. 6 times x is 6x. And 6 times negative 2 is negative 12. All right, now your x squareds, they cancel out. You have 4y is equal to, like terms right here become 4x minus 12. Well, my y is over here, and I'm almost done. I just need to get rid of that 4. So the opposite of multiplying by 4 is dividing, and I'm going to divide everything by 4. I get y equals, my 4's cancel, and I get x minus 12 divided by 4 is 3, and there was a negative sign there. So I just solve for y. All right, last part. Let's talk about closed sets. Now, we've already talked about closed sets a little bit when we said that integers were closed under addition and subtraction. So remember, when you have an integer and you add another integer, you get an integer answer. If you have an integer and you subtract another integer, you get an integer answer. So we said integers were closed under addition and subtraction. We also learned that polynomials are closed under addition and subtraction. So if you have the polynomial x plus 2 and you add another polynomial like x minus 3, will you get a polynomial answer? Well, remember, polynomials are polynomials because they have whole number exponents. There's no fraction exponents and no negative exponents. So this was a polynomial to begin with, and this is a polynomial to begin with. When we add them, or if we subtracted them, would we get a polynomial answer? Well, x plus x is 2x, and 2 plus a negative 3 is negative 1. And we ended up with an answer that is a polynomial. And that would work for both addition and subtraction. So we would say polynomials are closed under addition or subtraction. And we talked about that in an earlier lesson. Today, what we're going to do is we want to know, what about integers and polynomials being closed under multiplication? Question mark. What about integers? Are integers closed under multiplication? Well, let's try some examples. If you have 7 times negative 2, those are both integers. If we multiply them together, we get an integer answer. What if you have negative 4 times a negative 3? They're both negative. When you multiply them together, you still get an integer answer. So when you multiply two integers, you always get an integer answer. So therefore, integers are closed under multiplication. Okay, now what about, and they specify this in the book, they say one variable polynomials. Can you multiply two one variable polynomials and get another one? Well, what if you had a monomial, 6x, and you multiplied it by a binomial, 5 minus x squared? Notice those are both polynomials because they have whole number exponents. That means 0, 1, 2, 3, 4, 5, and so on. No negative, no fraction. If I multiply those together, I get 30x and negative 6x to the third. Did I get a polynomial answer when I multiplied two polynomials together? The answer is yes. So it looks like one variable polynomials, when multiplied together, are closed under multiplication. Let's try one more. What if you have x plus 2 and you multiply by 3x plus 4? Well, when you multiply, you get 3x squared plus 4x plus 6x plus 8. And when I simplify, I get 3x squared plus 10x plus 8. Is that still a polynomial? All of the exponents are whole numbers, so therefore we would say yes. Multiplying polynomials together, whether they're monomials, binomials, or trinomials, we will get a polynomial answer. So therefore one variable polynomials are closed under multiplication. Okay, and that is all for today.